Welcome to our first chapter of Chemistry 431. And so where do we begin? Well, we're going to begin with the structure of the atom, right? And all the details therein. And, in class last time, during our first class meeting, we talked briefly about the definition of inorganic chemistry. Roughly can be defined as the chemistry of everything except for carbon, although that's an approximation. There are inorganic compounds with carbon in them. But in this way, inorganic chemistry is the largest field of chemistry. And so it really ties very deeply into general chemistry and the chemistry of the entire universe. And chemistry is often called the central science because it's so fundamentally important to so many different aspects of how the world works and so many different types of technologies. And so we're going to be starting with the atom, and kind of paradoxically, the best way to start with introducing the atom is to talk about the very other side of things, the very large, okay? So the cosmos. And the way I want to introduce the kind of chemistry of the cosmos to you is with my favorite photograph of all time, okay? So my favorite photograph ever is shown right here. And, depending upon your screen resolution, this might not look like a whole lot. This image was taken by Voyager 1, okay, one of our first space probes that was launched into deep space, eventually still going into interstellar space. It was taken in 1990. And what you're looking at here are basically sunbeams that have been reflected off the camera. But if you look very carefully right here where my cursor is, there is a pale blue dot, basically a single pixel. That single pixel is our planet. And so this picture was taken 13 years after Voyager 1 was launched in 1977. And it's the furthest picture of Earth ever taken, 4 billion miles away about, okay? So this satellite, the space probe went out past Jupiter and its moons, and it collected beautiful pictures, some very beautiful pictures, high resolution pictures of Jupiter and its moons, and then it went by Saturn. And then after that, its mission was basically done. And astronomers were, getting ready for it to basically power down and see what else they could do with it as it launched into oblivion, right? But before it exited the solar system, right at the brink of the solar system, it turned around. The astronomers had it turn around and take this one last picture of space of Earth from deep space. And so, this is truly, I think, a remarkable image. It puts things into perspective. For me, certainly, I think, astronomy is a very humbling science, arguably one of the most humbling of the sciences, right? It shows us how small the Earth is in comparison to the rest of the universe, how small we are. But also, I think, how lucky we are to have how special our situation is, right? To have life on Earth, all these millions and millions of forks in the road and evolution that had to go right to lead us here today, to be able to learn about inorganic chemistry together, okay? And so here's sort of a model of what the spacecraft looked like. This is one of these early space probes, certainly not anything super high tech compared to what can be done now, but it's still amazing that this thing is still going. I think what this image also kind of represents to me is how fragile the Earth is, right? We're so little, but what we'll see in this course is that basically everything on Earth and in the greater solar system in the universe can be explained directly or indirectly through principles that are very deeply founded in chemistry and inorganic chemistry. And this is why, to me, chemistry is just a fascinating science. And I have zero regrets having chosen chemistry as my major. And if I had to, oftentimes I think about, if I were to go back to school, would I want to major in something else? There's a lot of fascinating fields: biology, geology, engineering, etc. But every time I really think about it hard, I know that I've made the right choice in majoring in chemistry. So a lot of you guys are chemistry majors, and so you've made a fantastic choice. That's great. So here's another picture, just of the Earth from Moon, just giving you an idea, right? It's just super beautiful where we live, and I think what hopefully we'll see through this course is just we'll gain a deeper appreciation for the complexity that is on our planet and is in the universe, how little we actually know, right? And how all the pieces have fit together to give this wonderful place, but also how things could go wrong, and what we need to protect one another and protect where we live, right? So I think no better person explains these sort of concepts than Carl Sagan. If you haven't heard of Carl Sagan, or don't know who he is, I really highly suggest you YouTube him. He was just a phenomenal explainer of science. He was an astronomer. He was actually the chief person in charge of Voyager 1. And he famously said that we are star stuff. And this is true in a very literal sense, right? This is how the big gets connected to the small, because the atoms that were created in stars, the atoms that were created in our sun in supernova explosions, are the atoms that make us up, that make up the Earth, that make up everything: the ocean, the rocks, every single type of life that has ever existed on our planet originated in the factories of stars. And so in the next video, we're going to dive deeper into that. But by this very nature, there's something, I think, incredibly profound, that you are in a very direct way actually connected to the past, and connected to each other and other parts of the universe and the world, right? Through the sharing of atoms. And so you are literally connected to the stars in this way.